Hello everyone, this is Logic Filter with a brief lesson in source criticism. There is a recurring problem with handling information, be it while doing research, observing or participating in debates, or just in everyday life. Whenever one receives information, there is always a chance that some of that information will be wrong. The problem lies in figuring out which bit of information is correct and which is not. This is often hard to do, especially if one is not accustomed to doing it. The problem is further compounded by the fact that among the information and disinformation there is propaganda, disinformation cunningly disguised as information, also known as active disinformation. In this video, I will try to teach some basic methods to differentiate between information and disinformation, and to see through propaganda. This process is called source criticism. Method 1. Justification. An important concept in verifying if a given statement is likely to be true is justification. Justification of a statement is simply the reason why we believe the statement to be true. In a strictly formal way, it is the logical chain of implication from something we know or assume to be true leading to the statement. A claim without justification is called an assertion. Well, in mathematics we might call it an axiom. You should never accept a claim without knowing its justification. I will dedicate some more time for justifications and why they are important in my future video about epistemology, the theory of knowledge. If no justification is presented, ask for it. If they cannot or will not reply, the assertion can be safely dismissed. What will often happen in debates and real life is that instead of a justification, you are given a reference to that justification, which brings me to my next point. Method 2. Checking the reference. A good way to quickly identify scientific material from non-scientific material is by its references. Any scientific article will list numerous sources that it bases its claims on. Sometimes there are a few, sometimes they number in the dozens. Ideally, this same process of source criticism should be applied recursively to all of these, but the fact of the matter is that the amount of such interlinked papers is simply immense. They have entire libraries full of that stuff. You could spend your lifetime going through it and you wouldn't necessarily see the end. For example, the American Mathematical Society maintains a database of mathematical publications, and they have 2,342,211 publications on file as of today, July 9th, 2008. And that's just a single database on mathematical papers. No scientist who has ever lived can claim that they know all of that, and they don't claim that. They don't have to. For one, scientists usually have a very specific field that they study, which limits the number of relevant articles. But more importantly, they can be confident that peer-reviewed publications are correct because the process of peer review enforces scientific rigor. I'll explain that in a video dedicated entirely to the scientific method. For the layman, it is enough to understand that just citing reference doesn't magically remove the need for justification. It still needs to be there. Creationist videos are rarely, if ever, bold enough to present their references, and that in itself should be enough to set off an alarm. If they do, it is usually a reference to a creationist website devoid of further references, or perhaps referring to some other biased site, but sometimes they actually refer to a scientific paper. In those cases, it is important to make sure that the claims made are actually supported by the article in question. Creationists can be very sneaky in misreferencing material. I don't mean to single out creationists in this case. They simply have a bad track record at this in my experience. However, one should apply the same criticism to every claim made, regardless of whom it comes from. Method 3. Multiple sources. This one is pretty simple and applies mostly to your own research. If you find a claim that is even remotely suspicious, you should seek out other sources and see what they have to say. Wikipedia deserves a special mention here because it has the tendency of mentioning if the topic is contested and what the different viewpoints are in a fairly objective manner. Using multiple sources has the added benefit of allowing you, the researcher, to see the subject matter from different viewpoints. This in turn allows you to grow to understand the subject in a more complete manner. Using multiple sources is a cornerstone of all research. Using only a single source will just lead you to copy whatever that source said on the subject and will probably not lead you to any true insight into the subject at hand. Method 4. Does it make sense? This is the simplest, hardest, and most powerful of the methods mentioned here. Does the claim made here make sense? Is it consistent with what you already know? If it doesn't make sense, ask the person making the claim to clarify. No subject is too hard to understand if broken down into simple enough components. If the person making the claim cannot break the claim down into bite-sized, easy-to-understand pieces, then the chances are good that he doesn't really understand the subject. One aspect of mathematical rigor, which is related to scientific rigor, is that every claim must be broken down into a series of indisputable subclaims. This is how mathematical proof usually works. If an argument cannot be understood as a whole, break it apart and see if you can understand the individual pieces. For example, I do not fully understand how mechanical clocks work, but I can be reasonably confident that if I took the clock apart methodically, examined the functions of each part, and worked my way through from what I understand to what I don't understand in small enough steps, I would eventually grow to understand exactly how a mechanical clock works. This method will, hopefully, lead to a fuller understanding of the subject at hand, or reveal the faulty logical underpinning of the claim made. In conclusion, the purpose of education and research is to increase one's knowledge. In order to do that, one must pay extra attention to not only memorizing conclusions, but to understanding the logical justification for these conclusions. If someone makes a claim that you do not understand, it is the fault of the person making the claim, not yours. In those cases, simply interrupt and ask for clarification. It is perfectly reasonable, and there is no shame in admitting that you don't understand something. By your question, you may reveal a logical fallacy that even the person making the claim hadn't thought of, and will lead to an increase in the knowledge of both participants. So, it is good to ask questions. I hope this has been helpful to some of you. As a small test, are any of the things I've just said true? If they are, why are they true? If they are not, why do you think they are not true? If you want, you can leave your justification on the comments below. In addition to the actual content of this video, I would like to add that in my last video I mentioned some people who gave me the inspiration to start making my own. And I forgot to mention one important person from that list, Andromeda's Wake, for his brilliant style guaranteed to keep even the most ADD of us glued to the screen, and for opening my ideas to the idea that this battle is not just for biologists. Thank you for that. Now, go out and check his videos.